Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, part of the Finding Genius Foundation. Today I have a little bit unusual guest, Michael Kennedy. He's the podcaster himself. He does two different ones, and he teaches Python programming and various applications. The reason why I want to have him on is that, in this podcast, I talk to literally thousands of researchers, clinicians, etc. And Python, at least at first glance, seems to be amenable to anyone in the sciences that wants to do some programming and to analyze data and things like that. So that's why I want Mike to speak to you. And we're going to find out how Python can be used, how easy it is, how accessible, et cetera. So Mike, thanks for coming.
Hey, Richard, thank you for inviting me. It's super to be here. Yeah.
Well, tell me a little bit about your background. Like, have you done other programming and, why did you fall in love with Python?
I guess I started out really wanting to be a chemist of all things. I loved like biochemistry, organic chemistry, that kind of stuff. And I had one challenge though. I'd spent a lot of time in the lab and just working with the chemicals kind of freaked me out, right? Like, oh, that's benzene. And, if you get it on you, it might give you cancer or other things that I'm just like, I don't know. I just end up getting headaches from all the, the volatiles and whatnot. And so I thought, well, this is really interesting, but I don't want to like spend my days in labs with fumes and whatnot. So I went on to study mathematics, which I was working on my PhD in math, and realized along the way I got sort of pulled into programming for working on some research projects. And I realized, I'd already committed a lot of time to getting into math, but I really enjoyed the programming side. I really enjoyed sort of taking the super theoretical side of what you might do in like a math PhD, but actually making something that people can use and interact with and feel. And that just felt so much like such a better contribution than, I solved some theorem and now people can build the next, solve the next theorem, right? So I went into that, and my first job actually was at a research lab in San Diego that was a whole bunch of cognitive science PhDs. And they were doing all sorts of research, primarily around eye tracking. Now, you see eye tracking these days, that sounds like an iPhone app. But way back then, it was EYE, right? Like, where do you look while you're doing things? And they would study stuff about cognition, about memory, distraction, and even like cognitive load. They had some really interesting algorithms that would look at the pupil dilation over time, factor out the dilation due to light, and then came up with a metric of, is this person mentally engaged in problem solving or not? That was insane. It was really cool.
Okay.
Well, I was going to say, so through that, I realized how interesting and powerful it was to take some of these programming ideas and apply them to these areas of scientific research. So a lot of these people had been building little simulations and little data analysis tools in MATLAB or other sort of low effort programming, semi-programming, computing environments, right? And they were doing amazing things. But then we would come along and apply like real programming, professional programming languages to it. And it would just go from, well, now we can go from analyzing, 10,000 data points to 10 million data points and make real predictions instead of, simulated predictions or rough estimates, right? So just really interesting things there, yeah. That's the
AI
programming
algorithms?
Origin.
With AI algorithms, are they amenable to Python?
Yeah, absolutely. So if you're doing anything with machine learning, deep learning, those kind of things, Python is the primary language, or certainly one of, if not the primary language, depending on what platform you're working with. So
nice.
When you look at, for example, I think it's on the helicopter, certainly on some part of the Perseverance rover that just landed on Mars, they've got some machine learning algorithms there. And those machine learning algorithm models were built with Python. And I think it has to do with the little helicopter, which is just so neat.
Yeah, that's really cool. If I'm a researcher and, I've got tons of data to analyze, how can I use Python without being afraid of it? And how can I harness it? Is it difficult to use? Like, what's required so that I can analyze my data?
Yeah, it's really not very hard. And there's all sorts of interesting use cases that are small and approachable. And so one of the things, let me take a little bit of step back and just set the stage. One of the things that I think is really missed a lot in the common conversation around, oh, we have the shortage of programmers and maybe we should have some more programming stuff, more programming curriculum in high school and whatnot. I feel like a lot of those kinds of conversations are around, we have programming jobs, we need to make a bunch of small programmers, grow them up, and then stick them in the programming jobs. And I think that really misses a lot of the value. There's so many people that are into amazing things, into research, into science, into other stuff. And with just a very small amount of programming, they can turn that into what I like to think of as a superpower, right? So if I'm a biologist and I'm out in the field doing research and I get, 10,000 measurements and I'm trying to measure those, say or analyze those, say with Excel or something like that, right? And plot it and understand it. You can do that, but there's a lot of challenges. There's only so much data you can process. It might be slow. With Python, it's one of those languages that is really simple to learn, but you can go much, much farther. So if you can think of, well, what could I do with Excel? There's a really simple library in Python called pandas, people might wonder, that you can just use and say, you can even read Excel files if you wanted, but you can just go and say, well, there over on the internet is data source. It might be a CSV file. It might even just be a Wikipedia page. You can just say, go load that Wikipedia page, find the third table down and turn it into what looks like an Excel table right live off the internet. And that's literally either 2 or 3 lines of simple code. And you've gone to the internet, live data, you've understood the web page, you've found, like, say, the third table, and you've turned it into an Excel sheet basically that you can analyze. And so there's these
super cool.
Isn't that neat? So there's, you're not going to go rebuild Mac OS or some game or what, like, you're not going to need to build like huge complicated things. You can solve these amazing problems. Like, well, we had the interns go and always collect that data and put it in Excel. Well, maybe they did that weekly and maybe every now and then they made a mistake. What if you could automate that so that happened once an hour and it never made a mistake? One of the areas of science that you'll see Python being used a lot has to do with reproducible studies, right? So you want to be able to do exactly the same thing over and over. And if you're kind of manually pulling all this data together and fiddling with it and whatnot, like, you might get into a place where you got a great result, but you can't remember how you got there for sure. You know what I mean? But if you can encode it into these simple steps and some of these simple tools like Jupyter Notebooks, which are like, if you've ever used MATLAB or something, it's a little bit like that. It's like a web page that you type some code into. You might put some latex, you might put a picture, some markdown, and then a graph, and that might be pulling live data. So you just put it into one of these notebooks and you save that and you make that part of your research paper. There's even places like the Journal of Open Source Software, JOSS, that actually publishes peer-reviewed software that usually accompanies some kind of article or journal paper. It's pretty neat.
Yeah, I know from using Excel, like in college, I did chemical engineering. Back then it was okay, because we would have, I don't know, maybe a few megabytes of data. But in biology, I've heard, a lot of people will have terabytes of data, petabytes of data.
Especially if it involves pictures.
It would never even load.
Yeah, it'll never get there. That's right. Yeah, the people at the Allen Brain Institute were doing all sorts of amazing stuff with Python and biology and like brain imaging and mice, trying to actually study and analyze the neural connections and all sorts of stuff with Python. It's pretty neat.
So Python can handle pretty much any amount of data quickly and it doesn't bog down?
Yeah, pretty much. So for, CERN, Python was central in CERN's discovery of the Higgs boson, which if anything that generates data, it's almost always going to be dwarfed by what CERN has going on. They've got an amazing multi-tiered layer global distribution just to like process and save the data. Also the I forgot the name, the huge telescope, the radio telescope down in Australia and South Africa. They've got just terabytes and terabytes of data coming in. They're all processing those results with Python.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Maybe more close to home for people, like YouTube runs on Python, and they get 1 million visitors or 1 million page views a second. So that's also another metric. Like you could take that kind of power and turn it against your research and your data. You can come up with some really interesting things.
What kind of equipment do you need to run it? Like, can you use Raspberry Pis so you can get in real close and local to your experiment and capture there and analyze?
Yeah. You can even get closer than that. So, I mean, obviously it runs on the main computers on my Mac here. It would run on that. I use that all the time. It runs on the cloud servers that like run, websites and stuff. But it gets really interesting because they put a lot of effort into making it very compatible with small things. So Arduinos, Raspberry Pi, for sure. That's a very common use case and a very easy use case. There's a lot of tools and frameworks there, but you can get even smaller. So there are like little tiny microcontroller things, like a $4 chip that you can buy that has Wi-Fi and, dual core processors, like a $4 little tiny, very, very power efficient microchip. Python will run natively on those things as well. So if you wanted to like do a research thing where you were having a bunch of small little IoT pieces, maybe solar powered or something, you could put that together with Python and some of these things. The best place to check out for those kinds of devices is a place called Adafruit. They're primarily about education, about teaching people small device programming stuff and making that very accessible, but also they just sell the devices and the platforms.
It's called Eat a Fruit or what?
Ada.
Adafruit.
ADIA or ADA Fruit. Yeah, I think it's just ADA Fruit. I can't quite remember how it's spelled.
Oh, okay. Huh. Interesting.
Yeah.
So you worked on projects, I believe you said with CERN directly and with this Brain Institute and a few others?
I wish I had. I interviewed the people who worked on them. So I interviewed somebody who was on the team that won the Nobel Prize for the Higgs boson, interviewed a couple of the research scientists from the Allen Brain Institute and stuff like that. So I like to find these kinds of stories and talk about them on my podcast and just kind of expose the cool stuff that people are doing every day with these programming languages that really like empower them to do way more than they would have expected.
So if I have like a fresh graduate student in my lab and I say, we don't know anything about processing data. We've just been sending it out, but we want to do it in-house. Go figure this stuff out. I mean, how much of a learning curve is there? Not
very much at all. It's one of these things that you can get kind of good at really, really quick, but it also takes you a lifetime to master. So, it's there's a T-shirt in the community that is a bit of a joke that encapsulates this. It says, "I learned Python. It was a great weekend." And to a degree, it's true. It's really much simpler than some of the other languages people have heard of, like C++ or Java or whatever. But it's nearly as powerful and as flexible in many like sort of low-level ways, but also in other ways. The sort of learning forever part is you can write programs in the language itself and the building blocks that come with it pretty easily, but there's this whole spectrum of third-party libraries that you can go get. So if you're interested in biology, go over there and grab a bunch of those libraries and start working with them. If you're interested in astronomy, there's AstroPy, and you can just grab that and start, working with your black hole analysis, like without programming the algorithms. You just say, I want to use that algorithm on this data. So the learning it for your lifetime is kind of continually finding and mastering these external libraries, which are, there's like 300,000 of them, and they're growing, 1,000 a day or something insane like that. Maybe 100 a day, but many more than you can learn a day. So that's the real power. What you could do is you could teach a graduate student, get them started. And I would say, get them in the scenario you've laid out. The idea would probably be Jupyter notebooks, Python and pandas, and get started, and then find some library that is specific to your space. If you're in astronomy, AstroPy. If you're in medicine or genetics, pick the library over there. There's a bunch of pre-built libraries that you could just work with there.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Oh, they called Pi, like AstroPy, BioPy.
Yeah, because it's the astronomy Python library. There's usually something like that.
Okay.
Yeah.
What are so if someone's just looking around and they're just starting to learn about Python, like what are some of the names that they'll look for? Just look up Python, or
I would say you would probably want to start out at a place called PyData. That's sort of the computational side of that space, as opposed to something like the web API website side, the database side that people probably don't care about. Got a bunch of libraries listed there. Also maybe SciPy, SCIPY would be worth looking at. That's like the scientific computing side. They've got some core data visualization and data processing libraries, and that's sort of the foundational building blocks that most scientists, folks in medicine or even economics, something like that, would use to start this data exploration and analysis. And then you would go find your specific libraries beyond that with just usually a Google search, Python plus, the thing I'm trying to do, and you'd be good to go.
Yeah. So what are some of like the really cool applications that you've been involved in or you've seen personally?
Let's see, some recent ones that I've talked to folks about that were pretty interesting. I talked to a guy on one of the Formula One race teams, and they were using originally Excel and a bunch of other tools they had pieced together to do the wind tunnel simulations and try to predict what they're going to do. And it would take forever. And they rewrote that stuff in Python and were able to, build their cars much better, faster, stronger, that sort of thing. I talked to this guy. He reached out to me to be on my show. And I don't know if this really makes a whole lot of sense to cover, because it doesn't sound that relevant at first, but then he told me the story. And I was like, this is amazing. So the guy is a librarian to some degree, but also a medieval Islamic philosopher. He studies philosophy of the Middle Ages, of the Middle East, like 400 to 900 AD, I think it was. And back then they would do a lot of their writing on scrolls. They would write in the scrolls. And there are two things that were particularly interesting. The guy name was Cornelius Van Lit, by the way, give him some credit. So there were two things that were distinctive about the scrolls that you could use to understand sort of who would cite who or who collaborated with who amongst the philosophers, and then also what time frame they were from. So largely the time frame would come from how the thing folded. So you would do the scroll, and then there would be a flap, like a flap that would finish off the scroll. And the flaps style and shape would change throughout the years. So if it had a certain style and shape, you could say, this is probably a 600 AD scroll or something like that, right? The other one was the collaboration. So you would get a big stamp, think of the stamp of the king that would put in wax and put it on to give to a messenger, that type of thing. And they would put that onto the scroll, and they had this very ornate pattern. But if you stamped it with this pattern, that meant, philosopher X had worked on it. And that was sort of the signature. So that sounds tricky to study, right? What he would want to work on is, well, who collaborated with this person? And show me all the scrolls that I've been reviewing from this era. Originally, they all did it by hand, and they could work on a couple. What he did as a non-programming person was he created a computer vision machine learning algorithm that would look at the scroll. It would identify the little stamps and say, oh, that's whoever. I don't actually know the names of the medieval Islamic philosophers off the top of my head, but that's Socrates type.
Smith, right?
Yes, exactly, right. No, that was Plato. Yeah, exactly. And he taught the computer to see the scrolls, to understand all the people who had signed it, and then create relationships amongst them, and then also to see the flap, and then to tell it to categorize what era it lived in. So imagine a person who is a philosopher, who is not a programmer, teaching a computer to do those things. And they went from analyzing, tens to hundreds to many thousands of scrolls, automatically, right? With fewer errors and so on. And so that's just such an empowering story. And he gave a really great presentation to all the other people in what they call digital humanities, just saying, you guys, look what I built. We can all do this. This is not really very hard. And it's really amazing let's all know that this is a superpower that we can leverage. Let's just go do that.
Do you remember what conclusions he came to, or what did he learn that he didn't see before by doing that?
You know, I think it's more about the thoroughness rather than new conclusions. It was like, now they can say for sure instantly who this person worked with, right? And who else collaborated with that person, because instead of having just a couple of scrolls to like pull data from, they have like most of them, right?
Well, there's this guy in math named Paul Erdis.
Oh yeah, I was a big fan. I still am a big fan of Paul Erdis.
Oh, but same thing with his, the Erdis number. If you did a paper with him,
yes,
or if you did a paper with someone that did it with him. I mean, I'm sure someone has nerded out and like mapped all that with all his 1,500 papers who did it with him.
Yeah, exactly. It's kind of like the Erdis number, but you don't actually know very much about the symbols. They're hard to read. It's not just like a name. It's a weird, funky symbol, and so you need to know, oh, this is not one we've seen before. This is a new person, and so on. Yeah.
Huh.
But it's a similar idea.
Yeah, that's really cool.
Yeah.
All right, what other juicy examples do you have?
Juicy examples.
If a one-eyed one-legged philosopher can do it, then anyone can.
Yeah, exactly. I mean, this guy he's also a monk. He's a really interesting character, but a very, very empowering story, and I thought that was pretty neat. I'll tell you one from the tech side a little bit, just because I think it's kind of interesting as well. But it's not as relevant to research, but it is kind of fun. And I'm sure it's something everybody has experience with. They just don't know it. So I'm sure almost everyone has at least watched one or two things on Netflix, right? And so right. Netflix has, many people probably don't realize, but they run actually on Amazon's cloud computing platform, AWS. And there's many servers that they use. I don't know how many, but it's in like the tens of thousands or more computers. They're all working in coordination to deliver you whatever show you get on there, right?
Right.
But there's so many variations of, well, if somebody's watching it on an older app on their iPad, now someone else is watching it on, their computer or their phone, and it's in this region. So it's talking to that data center, which is talking to this big complicated thing, and it's using this video codec. And so
they're like 3/4 of the way through it and they came back to it, and it has to start from that point.
Yeah, exactly. So they've got to coordinate all that stuff. And I don't believe the actual execution, the running, the delivery of the video happens with Python. I think it's something else like Java. But what's interesting is they need to understand when that huge number of computers has a problem, when it's not working right. And there's so many variations and so many permutations that it's hard for a human to look at it and go, oh, there's something wrong, but only for old iPhones with this operating system and this version of the app, right? So they built Python libraries to like understand the thing and sort of notice anomalies in it. And they also built this thing called the Chaos Monkey. And to make sure that they could handle servers crashing, networks getting disconnected, things going wrong, is they have this Python program running around in their data center, just randomly killing off parts of Netflix, server here, video stream there. And they do that on purpose continuously so that the people who develop software for Netflix have to develop assuming failure, because at a minimum, the Chaos Monkey is running through the data center, killing things. And that forces
chaos monkeys in our lives.
We do. And so they just made it explicit. And so it's explicitly this idea that you need to develop systems that are resistant or designed for failure in this way. And they just build it automatically into the system where it's just actively taking its own self out. So there's really interesting and weird things going on. There's also plenty of mainstream things, but yeah.
Huh. I kind of asked you already, but is there any other examples, no matter what industry, that you thought it was the coolest thing ever? Your favorite story about how Python has been used?
Oh, there are plenty, but I probably have touched on some of my favorites for sure. I would say certainly the computer vision philosopher one is pretty amazing. that one's out there. The discovery of the Higgs boson used a lot of the same tools that I discussed that you would start with, like the SciPy stuff and pandas and so on. They didn't actually collect the data with that. There's like all these layers, but they did the data analysis and visualization with that as well.
So so when someone first contemplates using Python, should they think first of just the data collection, or should they think of the analysis or the whole thing? Like, when you underestimating it, when you overestimating it?
Yeah, I would say, start with the data collection. And what that might be is maybe it means something like I described it. Go to this web page, understand it, get the third table and save that to an Excel file, and then hand that off to the intern, right? Okay, intern, here's the data from 2 hours ago that's live, and you can just work with it, right? That might be actually value right there. And that would be pretty easy to do. Or you could just do it on demand, right? Like I want to refresh the data, wait 5 seconds. There's your Excel spreadsheet with no errors. That's pretty cool. Certainly the next thing in the data pipeline that you would be thinking about is, well, if I've got data and it's not from a structured place like a table in a website, maybe even from there, it might have incorrect data. It might be invalid data. It might be just missing and so on. So the next thing is the data cleanup. And there's a lot of interesting aspects of one of the tools I mentioned called Pandas that says, well, if you find any missing numbers, make sure you put a 0 there, or don't include that row that has a missing number, and things like that. So it's about making sure that the data that goes into your algorithms or your research doesn't start out bad, because good data in, probably good answers out. Bad data in, probably bad answers out, right?
Makes sense.
So it's really easy. As part of that data collection side, the next thing to do is make sure that it works. And you can do that manually. You can do a little test. You can write a little bit of Python code. There's also interesting libraries. So this is part of that learn it for a lifetime, even though I learned it in a weekend type of thing, something called Great Expectations. And what it is a library that will continuously test your data that you've collected for expectations. I always expect this field to be between 0 and 1. I always expect this to be 0 to 360. And this has to be a number, and this has to be a string or a date. And you can just continuously run that against your data as you collect it. So there's this sort of first pass catching invalid data that might come in before it gets into your actual calculations.
Well, so you establish like these parameters vary between 1 and 10, and you figure that out early, so that in your experimentation, if it goes to like 20 or 100 or negative 50, something's wrong and it flags.
Yeah, you're like, whoa, the algorithms are not built to take it to a negative 50. And maybe that's okay now, but my algorithm is not okay to take it to negative 50. So let's figure out, is that bad data? Do I need to change my algorithm to deal with this new weird case that appeared? But it will not be a surprise to you, because the system will automatically be going, yes, it passes all the basic constraints of the shape and style of the data that I expected to collect.
So there's libraries for data collection. There's libraries for, I guess, it's not really analysis, but I don't know what you call it, like, I guess, shaping the data.
Yeah, I mean, there's a lot of statistical libraries and stuff that you might apply to it. There's a lot of easy ways to do like these transformations and so on. Maybe you've got some custom file format, like in astronomy they use, I was going to say IDL, but that's more the programming language. But a different fits. Let's say fits is like a table, but also image type format. So there's a way to just go load one of these fits files into a well-known data structure that I can work with. And you don't have to figure out how to do that or how to read all these complicated data structures. You just say, AstroPy, load that thing that you know about and give me the data as, like luminosity or whatever. I don't want to have to deal with trying to figure out how to read this weird thing. Just give me the answers, And
when you get to the point of analysis, what kind of libraries are there? I mean, are there like AI libraries, or will they tell you,
sure,
you don't have enough data to do this statistical analysis, get, 12 more points, or do they guide you in that way?
Well, I think that would be down, like the sort of restrictions or constraints or safety nets would all be down to the different libraries that you would use. So I'm not sure if they would be there, but some different fields have specific, algorithms baked into these libraries that you can run against them. And others, you can just use general statistical libraries and programming. It depends on exactly the kind of problem you're trying to solve, and if there's something somebody pre-built for that. There's a lot of, like I said, there's 300,000 different libraries. So there's a chance that there's one that does the thing you're trying to do.
Yeah, it's very cool.
And it's also worth pointing out that all these things are free, open source. They don't cost any money. You don't have to get research money to run them. You just install them for free onto your computer or onto your IoT device or your server, and then off it goes. So that's also really cool. Yeah. I mean, I know there's a lot of money in medicine, so maybe it's not as big of a deal, but at the same time, there's always just this friction, a hassle of, I'm actually in the wrong place and I don't have the license on this machine, but I want to do the research now. And you know what I mean? It's just like the ability to not worry about that stuff, even if the money itself isn't exactly the problem, is still really nice.
No, researchers will be interested because, they're going for grants and they have to allocate all the money on a grant. And the less they have to put on computing and this kind of stuff, the more they can allocate to another grad student or another few hours.
Absolutely. Yeah. Yeah. Or they could pay for some big compute cluster that'll let them answer the question faster. It's also worth pointing out that one of the things that's a cool advantage of something like Python or other programming languages, but I keep harping on Python, one, because I'm a fan, and two, because it's so accessible to scientists and the libraries supporting it are so powerful and plentiful. If I were to work in something like MATLAB or some other paid sort of siloed tool, you can do some really interesting things, but then you quickly outgrow it. It's like, okay, well, we built this thing in MATLAB, but now I want to run it actually as a service for all the other researchers to just connect to and get an answer and just sort of put it on the internet as something that people can use. And that gap is either an impossible chasm to cross or a very expensive or very hard one to do. Whereas Python's a general programming language, so it's super easy to put it out on the different cloud environments and take something you built and expose it as an API for the rest of the researchers, the rest of the world to get to. So that's also one of the really interesting aspects, is that the top of it is pretty high. Like I said, things like YouTube and Instagram and stuff are built with it. So you can put a lot of your research into production, as they say in this CS world, and make it available, beyond just something in your lab.
Well, very good. What's the best way for people to get started? You mentioned it earlier, but can we reiterate it? Where can they go from square one?
Yeah, absolutely. So there's really a couple areas to get started. You need to learn the Python programming language. It's not super hard to learn, but it is a programming language, so you do have to learn it. It's just easier than many of the other ones. And then I would say you probably want to learn the SciPy stack, primarily pandas, which is kind of like the programming equivalent of in Python of Excel. Right? That's the way you load the data into tables, and you can sort it and process it and filter it and so on. So Python plus pandas. I happen to have a place where people can learn Python over at talkpython.fm. But, there's many, many places on the internet where people can take online courses or get a book or whatever.
Yeah, and what's the name of your two podcasts? And again, where can they go? Let's say that slowly so they can find out.
Sure. So I have two podcasts, one called Talk Python to Me, where I try to tell evergreen, like deep stories, kind of like this Philosopher One or the Formula One. Those are all from that podcast. And then I have a second podcast called Python Bytes, and that's like a weekly newsletter, but in audio form with analysis, for like half an hour or something like that. So people can go either to talkpython.fm or pythonbytes, bytes.fm.
Very good. Well, Mike, thanks for coming on the podcast. It's again, a different angle, but super useful.
Thanks. I hope it inspired some folks to check out Python, because it really is one of the most powerful ways to supercharge your research. So good luck. And thanks again, Richard. It was really great to be here.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.